Good morning, students. Today I will take alkenes. In my previous videos, I explained you alkenes. Now today I will start alkenes, preparation of the alkenes, mechanism, and the properties. See, alkenes. These are the unsaturated hydrocarbons having a double bond between the carbon and the carbon, and its general formula is CnH2n, and these are also known as the olefins. Now, if you see the structure on double bond, here we take the example of the ethylene. Carbon-carbon double bond, in which carbon-carbon one bond is a sigma bond and second is a pi bond, and the carbon-hydrogen is also a sigma bond. So three sigma bonds and the one is pi bond between the carbon and the carbon. Now, this pi bond is weaker than the sigma bond. That's why these alkenes are more reactive than the alkanes. That is, unsaturated hydrocarbons, they are more reactive than the alkanes. Now, in the case of the preparation, first is from alkyl halides. It's very important. Here, if we take the example of the ethyl chloride that reacts with alcoholic QH. Alcoholic QH means when QH is dissolved in the alcohol. So reaction takes place. Ethyl chloride form the ethylene, potassium form the KCl, and the OH form the water. Now, what is the mechanism? How this reaction takes place? First, QH dissociates into potassium and the OH ions, and from ethyl chloride, this halogen is taking the electron and form the negative charge, so KCl is formed. Now here, important thing is that hydrogen for the OH to form the water is eliminated from the beta carbon atom. Beta carbon atom means the carbon next to the carbon having the halogen. So here it is alpha carbon, this is the beta carbon. So hydrogen from the beta carbon is liberated out and form the water content. This is also known as the beta elimination. So beta elimination means when the hydrogen atom is eliminated from the next carbon to the carbon joined with the chlorine. Now, for example, if we take the propyl chloride, it forms the propylene, KCl, and the water. Now, in the case of the higher alkyl halides, here we take the 2-chloro 3-methyl butane. When it reacts with alcoholic QH, it forms the two isomers. First, take the example when the carbon beta carbon atom is next to the carbon having the chloro group, that is, so here it forms the 2-methyl but2ane. Here beta carbon atom is this C and hydrogen is liberated from this and to form the 2-methyl but2ane. And in second case, it formed the butene 1, that is 3-methyl butene 1. Now here it is known as Set's rule. Now in the case of the Set's rule, it is found that the carbon atom having the more alkylated, which is more alkylated, it form a dominated product. That is 2-methyl butene is 80% and the 3-methyl butene 1 that is 20%. So this is in the case of the higher alkyl halides because they form the isomers. That is known as the Set's rule. Now from the alkynes. In the case of the alkynes, they undergo reduction simply ions, that is acetylene, to form the ene, that is the ethylene. Now here again, depending upon the catalyst. Now this butene when react in the presence of the platinum, deactivated platinum, that is platinum plus barium sulfate and sulfur, it forms the cis-but2A. This is known as the Linder catalyst. So palladium deactivated with barium sulfate and the sulfur, that is known as the Linder catalyst. It forms the cis-butane, that is 6-but2A. Now when we take a catalyst that is a wedge reduction, in this case sodium with liquid ammonia is taken as a catalyst. Sodium and liquid ammonia, that is known as the wedge reduction, it forms the trans-but2A and this trans-but2A predominates. So it's very important that when we are using the Linder catalyst, that is platinum deactivated charcoal with barium sulfate and sulfur, it forms the cis-but2A, and when we take sodium with liquid ammonia as a catalyst, that is known as the wedge reduction, it forms trans-but2A which dominates. Now third is vicinal dihalides. From vicinal dihalides. This vicinal dihalide means when the two halogen atoms they join to the adjacent carbon atoms. That is here CH2Br, CH2Br. When it heated with zinc in the presence of the alcohol, it formed ethylene and zinc bromide. So this is simply known as the dehalogenation reaction. So vicinal dihalide means when two halide groups they are joined to the adjacent carbon atoms, and when heated with zinc in the presence of the alcohol, it forms the ethylene and zinc bromide. So this is known as the dehalogenation reaction. So this is the preparations. Always try to understand the mechanism of the reaction. That is very much important. So here, that is the beta elimination. It's very important in the case of the alkyl halides. Remember always that the beta carbon atom hydrogen is taken up for the formation of the water content. That is the beta elimination, and this is the Sedgwick rule. And here the reduction by the two different catalysts. Okay, so if you like my videos, please share and subscribe. In my next video, I will explain more preparations with mechanism. Thanks very much.